Okay, so we are solving the 1997 AB1 calculus problem. The question is, a particle moves along the x-axis so that its velocity at any time t is less than or equal to 0 is given by v of t equals 3t squared minus 2t minus 1. The position x of t is 5 for t equals 2. Okay, part A is asking us to write a polynomial expression for the position of the particle at any time t is greater than or equal to 0. The first step, you're going to set the position equal to the antiderivative of the velocity, and you'll find that the antiderivative formula is t to the n plus 1 divided by the n plus 1 plus c. So this is our velocity formula, and by integrating that, we will get the position formula. Part 3, this is the integrated version of the velocity, which equals the position. And you'll see that by using this formula and plugging it into this, you'll get this. Next, you're going to find c using the point given 2, 5, and that is found up here in the problem when x of t is 5 for t equals 2. So you're going to plug that point into the position formula. So plugging 5 in for the x of t and 2 in for the t, and you'll get this, plus c. And then as you work that out, you get that c equals 3. So then you're going to plug c back into the original position formula. So you'll get x of t equals t to the third minus t squared minus t plus 3. Okay, so for part B, we have for what values of t when t is greater than or equal to 0 and less than or equal to 3 is the particle's instantaneous velocity the same as its average velocity on the closed interval 0 to 3. So the first thing you're going to want to do is find the average velocity, and you can find that the same way as you find the slope, so y2 minus y1 over x2 minus x1. So since we have the closed interval 0 to 3, we're going to use those values for our formula. So you're going to find this value by plugging 3 into the position formula, and find this value by plugging 0 into the position formula, and then that would be over 3 minus 0 because that's the numbers that we're plugging in. And you'll find that that equals 18 minus 3 divided by 3, which equals 5. So next we found our average velocity, so we're going to want to set that equal to our instantaneous velocity, which is just v of t. And so that's what this is. This is 5, our average velocity, set equal to the instantaneous velocity. And then from here we're going to solve for t. So if you just subtract 5 to get this equal to 0, then you get 3t squared minus 2t minus 6 equals 0. And then since this is a calculator active problem, you're going to want to plug 3t squared minus 2t minus 6 into y1 and 0 into y2 and find the intersecting point. And that will give you where the instantaneous velocity and the average velocity are the same. And that's what the question is asking. So you'll find that that point is at t equals approximately 1.786. And you always want to round to 3 decimal places because that's what they ask you to do on the AP exam. Okay, so for part C, we're going to find the total distance traveled by the particle from time t equals 0 until time t equals 3. So we have our velocity formula, which is 3t squared minus 2t minus 1. So we're going to start off by factoring and solving for t to find the critical points. So when you factor this equation, you get 3t plus 1 times t minus 1. And when you solve for t in both of those equations, you get t equals 1 and t equals negative 1/3. The t equals negative 1/3 is irrelevant to our problem because it's not within the parameters of 0 to 3. So we just disregard that one and just focus on the t equals 1. So the next we're going to create like a mini number line using our endpoints 0 and 3 and 1, our critical point. And in between these values, you're going to want to find if it's increasing or decreasing at those points. So to do that, you can plug in a number between 0 and 1 into the velocity formula, which for instance I used 1/2. And when you plug 1/2 into this equation, you get a negative number, so you know between 0 and 1 your function is going to be decreasing, so you put a negative. And then you want to plug in a number between 1 and 3, which I use 2 because that's the easiest. And you want to plug that into the velocity again, and when you plug that in, you get a positive number, so you put a little plus sign. And then, so for part 3 of this question, you're going to find the values using the position formula of the endpoints and the critical point. So those values, I found them for you, but all you do is plug them into your position formula. So x of 0 equals 3, x of 1 equals 2, and x of 3 equals 18. So to find the total distance, you're going to find the distance between these 2 points, which is 3 minus 2 is 1. And then you're going to add that to the distance between these 2 points, which is 18 minus 2 equals 16. So 1 plus 16 equals 17, and that is your total distance.